Screen is visible?
Sir, is it visible, sir? It is visible.
Sorry.
Okay.
Okay. In the previous class, we discussed about CAN bus, started talking about CAN bus. What is a CAN bus? We told it was developed by Robert Bosch, correct? Specifically for automotive communication, a wired communication system. Already we talked that what is important parts of the CAN bus, correct? So it has a two-way communication system which can transfer data from 125 kilobytes to 8 megabits, and it can send 2048 different messages because it uses 11-bit identifier. So 2 power 11 equal to 2048 different messages can be transmitted. Already we saw that. Then one more thing also, each device connected to CAN bus is called as a CAN node. So the CAN nodes can send and receive data. And then already we talked about it is a twisted pair wires. So the EMI noise is considerably reduced. And also it uses differential bus. Yes, we saw differential bus up to this also we looked into it, correct? And so the important component of the CAN bus is CAN node. Inside the CAN node, you need 3 items. One is the application layer software, and which will be embedded inside a controller. That is a microprocessor which does this on the CPU of your embedded controller. This embedded controller needs to be connected to a CAN controller. CAN controller is very important, which only generates the CAN message. That means adding the data plus start of the frame, end of the frame, CRC, many things are there which we are going to see today. All those things will be done by the CAN controller. The CAN controller can be in some easy, especially microcontrollers, right? Microcontrollers like C167CR or even other microcontrollers has a built-in CAN controller. Then you need CAN transducer. Please notice these are important hardware requirement in the CAN bus. Okay, so when you say CAN bus, these 3 parts becomes very important: CAN controller, CAN transceiver, and CAN wire, actual physical wire, which are these are all hardware. So this is an IC, integrated circuit. This is again an IC. This CAN transceiver converts the data to be transferred from 0 to 5 volts into high and low. Already we saw. We saw that it is transfers into CAN H and CAN low as a 2 different voltages. It uses a differential bus. Already I explained what is a differential bus. In I think previous somewhere we have talked about differential bus. Yes. Yeah, here. So you can see that whenever it wanted to transfer 5 volts, that is logic 1, which is emitted by the microcontroller. Okay, microcontroller sends 0 or 5 volts depending upon logic 0 or logic 1. This generates the voltage, this differential voltage, which is transmitted in the wires. This is the wire which we call a CAN bus wire. When you call CAN H, CAN low. Okay, so because of that, since the data is transferred as a differential voltage, which reduces RF noise. Apart from twisted pair, this also reduces the electromagnetic noise interference. Finally, okay, in CAN bus, the high voltage is called as recessive. 0 volt, logic 0 is called a dominant mode, a recessive mode. Correct? There are 2 things accordingly. CAN voltage. This voltage is from microcontroller. This is a CAN transceiver. This IC converts. This IC converts this 5 volts into this voltage, and which is sent through wires. Okay. So this voltage is called TTL level voltage. which is generated by the microcontroller. Correct? Detail, all the detailed devices generate 0 volts or 5 volts, that's a logic 1 or logic 0. Represented by 5 volt this one. So that is converted to plus or the high is called as plus 3.5, if I'm correct, it is 3.5 to 1.5 or 1.25 volts. Between this, normally it will be maintained at 2.5 volts. The difference voltage is, when you want to transmit 1, the difference voltage will be 0. When you want to transmit logic 0, the difference voltage will be 2 volts. No doubt. You can see that logic 1 is called a recessive. This is logic 1. During the time, the difference voltage between these two voltage will be 0. Okay. When you want to transmit 0, which is called dominant, that time one line high will become 3.5 volt. This is become 1.25 volts. Okay. It can become 1.5 volts. 1.5 volts minimum. Please note that it can be little higher also, but generally you need to maintain minimum of 2 volt difference. From here, it goes this side 3.5 volts, this side 1.5 volts. So difference is 2 volts here. If you are getting one is 3.5 volt in CAN H and 1.5 volts in CAN low, correct? You know that it is called as dominant bit, which is nothing but logic 0. If the difference, both will become almost close to 2.5, both the line become 4. That means CAN H also 2.5 volts, CAN low also 2.5 volts. The difference is 0 volts. Please note that in CAN bus, you never transmit 0 volts. CAN H, CAN level, one will from 2.5 will go to 3.5 volt, other will come to 1.5 volts. The difference voltage is very important. That's what I wanted to mention. So that is advantage. Already told about 7 layer, all those things. We also talked about what are the different this one. As I told you that many layers are there, in which physical layer is this. This is the physical hardware. IC plus wire, right? CAN transistor, CAN controller, correct? We know that CAN controller, correct? CAN transceiver and CAN controller and the physical wire. These are called as this one physical layer. The whole thing is called physical layer. All other things, medium dependent, physical, these layers, application layer, present layer, session layer, transport layer, network layer, logic layer, all these things are implemented using software algorithms. But you have to write. When you are designing my CAN control for your device, if you are developing a ECU in which you want to use a CAN bus, you will be developing this application layer software and also interface a CAN control transistor to your microcontroller, ECU of your embedded controller. This is ECU, embedded controller, or CPU, central processing unit. It can be DSP processor, a microcontroller. That will be interface. That's what I shown here. Right? These are things additional. This is your ECU of your embedded controller. Again, I told you, some of the ECU microcontrollers can built-in CAN controller. The blue color can be part of the microprocessor itself. So while if you are part of the this one where you are going to select designing the CAN bus for your this one, you can select appropriate microcontroller so that you can reduce one number of IC. One count of IC can be reduced because some microcontroller built-in CAN controller. That is advantage. One example is this IC microcontroller C167CR. It is from Philips company, if I am correct. This is from Intel. Intel microcontroller. This is CAN controller, again from Intel only. Then CAN transistor IC. So you need 3 ICs. In this case, this is a single IC. This is another 2 ICs only. Okay. So already we talked about it. This one. Yeah, again I showed you that it can go up to 3.7 volts. Generally 3.5. Normally I told you this is 1.5. The difference should be 2 volts. Difference voltage should be minimum 2 volts. But during implementation, it can go as high as 3.75 volt. In CAN high, CAN low can become 1.25. Right? But please know that it never comes to zero. This is 0 volts. The CAN 2 wires will be oscillating between these two voltages only, depending on what was this one. Already we talked about CAN frame. This is what I stopped, if I'm correct. So CAN message. In the CAN bus, data is sent as a frames, which we call message frames. There are 4 types of frames are there. One is called data frame, other one is roommate frame, other one is error frame and overload frame. The main data frame only actually going to transmit your data between two controllers. So then remote frame is used for broadcast by a transmitter to request data from another node. So for example, we have two nodes. Say that node 1 connected to node 2. Okay, so this is CAN bus. Now this is sending data. Then it is called CAN master, or which is transmitting data is called bus master. Okay, so this data will be received by all the devices which are connected in parallel. For example, there's a node 3 also. I told you can go up to 256 nodes are possible. Correct? Now, when we transmit this, the data goes to all. Then, depending on our message, whichever node wants the data, it will take. Every node will be listening. Correct? This node 1 is transmitting. It become a bus master. During that time, remaining nodes will be listening, including the node which transmit. It also will listen to the bus, because it transmit also will receive. It is also to listen to the data. It's a common bus, no? All the devices in the bus, there are 3 devices connected by CAN bus. If this device is transmitting, this device also will listen. It will transmit, also listen. Other 2 devices also will listen. Correct? So, sometimes they call slaves. The data received by is called slaves. Who is transmitting is called a bus master or master. Okay. Now, when you want to transmit data, master will this one. Now, suppose the CAN, instead of transmitting data, I want data from this one. The node 1 want data from node 3. Then what you can do, you need not transmit data frame. I will tell you what it can send a remote frame. Remote frame will not contain any data. Okay, I will explain what it is. If the node 1 sends a remote frame requesting node 3 send data, node 3 will send data. Without sending data, you can ask data from other nodes. That is that kind of frame is called as remote frame. The error frame is transmitted by any node that detects bus error. For example, the node 1 sends data, node 3 finds that the data received is corrupted. Correct? Data is corrupted. So immediately node 3 will raise error frame. The data sent by you as an error. Correct? It can send the error frame. Any other